10, age 11 months. Are you ready? Then let's go!
It's time for Maths with Mr. Thomas.
Welcome to Chapter 2, Lesson number 8. This is a review lesson for the fractions chapter. Just like all the other review lessons, it doesn't include every slide and every example, and I don't go over everything in a lot of detail. This is just me skimming over the key points so you can make sure that you remember everything in the fractions chapter. If there's anything you're unsure of, look back at those individual lessons. Got it, Morgan? Good. Then we started off the fractions chapter looking at simplifying fractions and equivalent fractions. What's that all about? Take a look at these fractions here. You can see that they're all the same. It is the same amount that has been shaded in each of these diagrams, which means that this 1/3, the 2/6, and the 4/12, they're all the exact same. They are known as equivalent fractions because they are the same as one another. In order to create a fraction that is the same as a fraction that you are given or you currently have, what you do is you multiply the numerator and denominator by the same number. So you can see here the 1 and the 3 have both been multiplied by 2. 1 times 2 gives you 2, 3 times 2 gives you 6. So we end up with this fraction that's 2/6, but that's the exact same as the 1/3, and it is known as an equivalent fraction. So for this example here, I asked you to write down a fraction that was equivalent to 1/2. Well, you can see that all you have to do is multiply the numerator and denominator by the same number. You can pick any number you like, pick a whole number. If you multiply the numerator and denominator by 4, so you multiply the number at the top and the number at the bottom both by 4, 1 times 4 is 4, 2 times 4 is 8, so 4/8, or if you got 4 out of 8 in a test, that's the same as half marks. So they're equivalent fractions, a half and the 4/8. If you picked another number, say 7, again you can pick any number you want, pick any whole number you like. If you multiply them both by 7, you get 7/14. So if you multiplied them both by 23, you would get 23/46. Again, these fractions here that we end up with, they're all the exact same as 1/2. So they're equivalent fractions. As well as creating equivalent fractions, sometimes what we'll get is a fraction where the numbers for the denominator and numerator are larger than they need to be. And what you can do is you can make them smaller. You can simplify those fractions. So say here, if we add the 2/6, well, we know that's not the simplest way of saying it. The simplest numbers would be using 1 and 3. And the way you can do that is dividing both the numerator and denominator by the same thing. Again, stick with whole numbers. With the 2 and the 6, they both divide by 2. So if you divide them both by 2, you end up with the 1/3. So that is how you can simplify fractions. With some examples, this one here, we had simplified the 12/15. All we have to do is think, what times table is 12 in and 15 in? They are both in the 3 times table. So because they are both in the 3 times table, divide them both by 3. If you divide them both by 3, you get 4/5. Meaning, a simpler way of saying 12/15 is just to say 4/5. It's the same thing. So all you have to do is look at what times table they're in and divide by that. If you have 24 out of 32, so 24/32, well, again, to simplify that, you could think, oh, they're both in the 8 times table, and you can divide them both by 8. Woo! High five if you do. But you could also think, well, they're both in the 2 times table. There's an even number on the end of each number, so they both divide by 2, so you can divide them both by 2. However, if you get an answer of 12/16, just make sure that whatever answer you get, it is simplified fully. With 12 and 16, you could divide them both by 4, and if you do that, you would end up with 3/4, or you could divide them by 2 again, and you get 6/8. But if you get 6/8, again, think, what do they both divide by? They both divide by 2. So divide them both by 2 and you get the 3/4. So either way, no matter which way you're doing it, the 3/4 is the simplest form for that answer. Woo! After simplifying fractions and equivalent fractions, we then went on to look at proper, improper, and mixed number. What is that, Olivia? The type of fractions that you get. It is indeed. There are 3 types of fractions: proper fractions, improper fractions, and mixed numbers. A proper fraction has the numerator smaller than the denominator, so the number at the top is smaller. So 1/2, you can see the top is smaller. 7/12, again, the top is smaller. The same with 9/20 or 50/1000. The number at the top is smaller, so it's known as a proper fraction. If it's the other way around, if the number at the top is bigger, it is known as an improper fraction, as you can see here. And a mixed number is when you have a whole number part and a fraction. For example, if I ate 1.5 cakes, well, that 1 is the whole number and the half is the fraction. So because I've got both of them, it's known as a mixed number. With these three types, you have to be able to change between them. So with these ones here, going from a mixed number to an improper fraction, what do? So if you had 1.5, all you do is you take the whole number part and multiply it by the denominator. So you do 1 times 2, and then you add the numerator, so add the number at the top. So you do 1 times 2, add on 1. What does that give you? 3. And they'll stay with the 2 on the bottom, so you'll have 3 over 2. And that there is the same as the 1.5. It's just writing it as an improper fraction. Other examples are the same. If you want me to go over it in more detail, look back at that lesson. We also have to be able to change back the way. So if we get 9/2 or 9 over 2, we need to rewrite that as a mixed number. So we're looking for a whole number part. And the way you do it is you divide the numerator by the denominator. So you do 9 divided by 2, or how many 2's in 9. Whatever answer that is will be your whole number part. You will also have a remainder. A lot of the time, you can see down here we didn't have a remainder. But a lot of the time you will get a remainder, and that will be the top number. That will be your numerator. So 9 divided by 2 is 4 remainder 1. So 4 is the whole number part, and the 1 is your numerator. And because it's halves we're working with, we just keep the denominator as halves. So you can see here your fifths. So the denominator here is fifths. This is sevenths, keep it as sevenths. This one here, 56 divided by 8, goes 7 times. There is no remainder. Really, that one there is not a mixed number. It's just going to be a number, but sometimes you will find that there will be no remainder, and you would just write that with the whole number. After that, we then went on to adding and subtracting fractions. Disha, you loved that, didn't you? Yay! So, if you look at these two fractions, we've got the 2 quarters and we've got the 1 quarter, we can easily add them together. And the reason we can easily add them together is because the denominator is the same. We've got 2 quarters and we've got 1 quarter, so we're adding quarters, 2 quarters. Woo! How many do we have? Well, we've got 2 of them, we're adding 1 more, so we've got 3 quarters. However, dun dun dun, if we have, say, 2 ninths and we add on 3 sevenths, well, that's harder to get. We don't know what that's going to be. And the reason is because there are different sizes. This one here is ninths, this one here is sevenths. The denominator is different, so we can't just add the numerators the way we did before. What you have to do is use your knowledge of equivalent fractions. So, with this example, if you have 1 quarter plus 2 ninths, oh, the numbers at the bottom are different. What do I do? What do I do? Well, you think about the 4 times table. 4, 8, 12, 16, 20, and so on. You think about the 9 times table with 9, 18, 27, 36, and so on, and you find the smallest number that's in the 4 and the 9 times table. The smallest number is 36, so you want to change the 1 quarter to something over 36 and the 2 ninths to something over 36. What you then do is you think, well, I'm changing the quarters to 36ths, so I'm changing the 4 to 36. So you have to work out what you're multiplying that by. So 4 times what gives you 36? Well, to work that out, you could just divide, go the other way. So 36 divided by 4 is 9 times. So you know, to go from 4 to 36, you would multiply by 9. Because we've multiplied by 9, you have to multiply the numerator by 9 as well. So you do the 1 times 9, giving you 9. It's the same as your equivalent fractions. So 1 quarter is the same as 9 36ths. With this 9 here, I'm changing that into 36. So again, I think, how do I change the 9 into 36? And the way you do it is you multiply by 4. Well done. So you're multiplying by 4. So what do you also have to do? Good, you multiply the numerator as well. So you do 2 times 4, giving you 8. So again, changing the 2 ninths into 8 over 36 is just what we did with equivalent fractions. You're multiplying both numbers by the same thing. Because you got 36 in one fraction, 36 in another fraction, you can just add the numerator. So you're working out how many 36ths you have. And in this case, it's 17 36ths. Woo! And what do you have to remember to do at the end, Daniel? Brilliant. Always check to see if you can simplify your answer. 17 and 36, you can't divide them by the same whole number, so you can't simplify it. So that there will be your answer. With this next example, example 4, in that adding and subtracting fractions lesson, you will see here we had 1/2 take away 3/8. If I end up with a mixed number, a lot of the time what I like to do is change that to an improper fraction first of all. So 1.5, 1 times 2 is 2, and 1 is 3, so that's the same as 3 halves, or 3 over 2. That is how I like to answer these questions. I'll show you in another example, another way of doing it, but a lot of the time if you get a mixed number, I would change it to an improper fraction first of all. After that, you're just doing the same thing. Think about the 2 times table and the 8 times table. If you think about the 2 times table, 2, 4, 6, 8, 10, 12, think about the 8 times table. What's the smallest number that appears in them both? Well, it's actually 8, so you want to change them both into eighths. The 2 to the 8, what do you multiply that by in order to get to 8? Well, it's 2 times 4. So because you're multiplying by 4, you multiply the number at the top by 4 as well. So 3 times 4 is 12. To go from 8 to 8, well, really, we're not doing anything with that. I suppose you could think I'm timesing that by 1. 8 times 1 is 8, but you're just leaving that as it is. So you leave the top as it is as well. After that, we've got 12 eighths. We're taking away 3 eighths. So we've got 12 of them. We're taking away 3 of them. So how many eighths are we left with? Well, we're left with 9 eighths. You are perfectly right, Lewis. Because you have the number at the top bigger than the number at the bottom, it's an improper fraction. And if you're left with that for your answer, rewrite it as a mixed number. So think 9 divided by 8. Well, that's 1 remainder 1. So the 1 is your whole number part, and the remainder of 1 is going to be your numerator. And because you're working with eighths, keep that just as eighths. There is another way of working these questions out, so I will show you here. One way of doing the 2 and 4 fifths, add the 3 and 3 sevenths. Well, you could always do it just the way I did in the last lesson. Change the mixed numbers to improper fractions. After that, you want to look for the lowest common denominator, so the 5 times table, 7 times table. How do you go from 5 to 35? How do you go from 7 to 35? And then you can add the numerators and then just divide to change your improper to a mixed number. Look back to the lesson if you're wanting this in more detail. Again, I'm skimming over this just so you can be like, I've got that, thank you. And then another way of doing it is you've got the 2 and 4 fifths plus the 3 and 3 sevenths. Well, because you've got 2 whole number parts and you're adding on 3 whole number parts, you can just gather them together. So now I've got 2 full things, I've got 3 full things, but I'm also adding the 4 fifths and I'm also adding the 3 sevenths. But right away you think, well, I've got 2 of them and I'm adding on 3, so right away that's 5. And then just add these fractions together by again getting the lowest common denominator with 5 and 7. Well, that'll be 35. To go from 5 to 35, you times by 7, so you do 4 times 7, it's 28. To go from 7 to 35, you times by 5, so 3 times 5 is 15. After that, work out how many 35ths you have. So you've got 28, you're adding 15, which is 43 35ths. And then, because this is an improper fraction, do 43 divided by 35. Well, that's 1 remainder 8, so you can rewrite that as a mixed number. And you know from there, well, you've got 5 wholes, and you're adding in another 1 whole. So how many wholes have you got? Well, you've got 6. So you've got 5 whole parts, another 1 whole part, which is 6 whole parts. So there's 2 methods for doing that. Pick whichever method you like. After adding and subtracting fractions, we went on to look at multiplying fractions. For multiplying fractions, the way it is done is simplify your fractions if possible, then multiply the numerators together, and then multiply the denominators together. What I mean by simplify if possible is look at each fraction. So 1/2, can you simplify a half? No. Can you simplify 3/4? No. Look at the numbers diagonally across from each other, the 1 and the 4. Can you divide them both by the same thing without going into decimals, remainders and so on? No, you can't. The 3 and the 2, can you divide them both by the same thing? No, you can't. So all you do is you multiply the numbers at the top together. 1 times 3 gives you 3. My numbers at the bottom, 2 times 4 is 8. So 3/8 is our answer. With this example here, again, 2 sevenths doesn't simplify, 1/4 doesn't simplify, but the 2 and the 4, if you look at the numbers across from each other, they both divide by 2. So 2 divided by 2 is 1. 4 divided by 2 gives you 2. So if we cross that out and rewrite these numbers as the 1 and the 2, I'm just rewriting that to make it a bit clearer. I've now got a 1 in the top and a 7 in the bottom. I've got the 1 in the top and I've now got a 2 on the bottom. So I've simplified, and now I just do 1 times 1, which is 1, and 2 times 7, which is 14. If you don't simplify first, that's absolutely fine. You could also do just 2 times 1 gives you 2, and then multiply the numbers at the bottom. 7 times 4 gives you 28, so you could just go, that's going to be 2 over 28, and you'd be perfectly right. But you then have to simplify that, so you're thinking, what do they both divide by? And if you divide them both by 2, you would end up with 1/14. Pick whichever way you prefer, but I'd probably recommend simplifying first of all. What you don't want to do is end up with large numbers and think, oh no, what do I divide by? We don't want that. So, if you divide when it's smaller numbers, it's far easier than multiplying first to bigger numbers and then thinking, oh, 56 and 80, what do they both divide by? So simplifying first is what I would do. Here is a worded question. Let's work out the area of the rectangle. So you're thinking, oh, that's length times breadth. So you're just multiplying these two fractions together. If you're multiplying and you end up with the two fractions, what you have to do is change your mixed number to improper or top-heavy fractions. First of all, do that. See if you can simplify. Well, the 5 and the 5 both divide by 5. 5 divides by 5 to get 1. 5 divided by 5 to get 1. Rewriting that, and then just multiply the numerators and denominators together. It's an improper fraction, so rewrite it as a mixed number. So, a worded type of question. After multiplying fractions, we then went on to dividing fractions. Charlotte, did you enjoy it?
Yes, very much so.
Good. So to divide fractions, it's dead easy. All you do is you take the fraction on the right. So in this example here, so 3/7, you flip it upside down. So you get 7/3, and then all you do is you change the divide to a multiply and you carry that out as if it was just a multiplying fractions question. You'll get your answer, and woo! Well done. To divide fractions, once again, we have mixed numbers. Oh no! What do you do if you have mixed numbers? Perfect, change them to improper fractions. So with these two, we're rewriting them as improper fractions. After that, follow the same rules. Take the fraction on the right and flip it upside down. Woof! Bump! After that, you're just back to multiplying fractions, so the divide becomes a times. Look and see if you can simplify either of the fractions or the numbers across from one another. Here, the 6 and the 4, which are across from one another, both divide by 2. So 6 divided by 2 is 3, and 4 divided by 2 gives you 2. Rewriting that to make it easier to see, I've now got 19 and the 3, and I've got the 2 and the 7. Multiply the numerators together, multiply the denominators together, and woohoo! You got it. After that, with adding, subtracting, multiplying and dividing fractions, what we did was we threw in more than one calculation. And whenever there's more than one calculation, you use the word Bidmas to remind you of the correct order. The B stands for brackets. You would do anything in brackets. First of all, the I is for indices, which is your powers and your roots. You would then do them. Then it moves on to divide and multiply. Make sure though that if you only have divide and multiply, do that from left to right. The divide does not come before the multiply if it's just divide and multiply. Do it, as I said, from left to right. And then finish off with addition and subtraction. And again, if it's only add and subtract, do it from left to right. Add doesn't always come before subtract. If it's only add and subtract, work through from left to right. With this question here, we have the 3/4 takeaway, the 2/3 multiplied by the 1/5. So we've got a subtraction and you have a multiply. Thinking of your word, Bidmas! What would you do first? Well, there's no brackets, there's no indices. Divide and multiply, yes, we've got multiply here, so you would have to work this part out first of all. Because of that, the 3/4 takeaway will stay as 3/4 takeaway. We are not changing that. All we are doing is multiplying these fractions together. So see if we can simplify it, then multiply the numerators and denominators together. After you've done that, well, you're back to this dead easy question. This is just a subtraction question, subtracting fractions, and you're just back to what you were doing a few lessons ago. Find your lowest common denominator, and then take it from there. With this question here, once again, there's more than one operation. We've got the multiply, and we've got divide. Think about Bidmas. Brackets, indices, there's neither of them, but there is a divide and a multiply. There is only divide and multiply, so we would work through that from left to right. We don't do the divide first and then the multiply second, you just do it from left to right. So you would work them out, first of all, as improper fractions, and then from there, what you can do is you can multiply these two fractions together first of all, and then you can divide them by this fraction. You're going to do that as the second calculation. Again, to divide fractions, turn the fraction on the right upside down, change it to a multiply, and woohoo! You're back to what you have been doing with those other questions. This one here we had 2/3 of. This comes up in past papers quite a lot of the time. If you ever see an of, what does of mean? Times! Brilliant. Of just means time, so it means the 2/3 times by what is in the brackets here. But again, we're multiplying, we've got subtraction and we've got brackets. Thinking about Bidmas, you have to work out anything that is in the brackets first of all. So first of all, work out the 3.5, take away 1.25. Rewrite these as improper fractions, get the same denominator, get the lowest common denominator, and then you can subtract. From there, you're just back to a multiplying question. See if you can simplify first of all, or multiply after. Again, it makes no difference, as long as you get that 1.5 as your answer. Woo! High five. That is it for fractions. At the end of that, after the simplifying and equivalent, proper, improper, mixed number, add, subtract, multiply and divide, and Bidmas, what I did was throw in the lesson looking at past paper questions. So if you're wanting just a chunk of these past paper questions and me going over it, explaining it, look at that lesson. Probably pause the video as you go through it as well. Give yourself the question, try it on your own, and then see if you get the right answer as I go over it. Or just skip me to see if we get the same answer, and just check you're working as well. But that is the review for fractions. Hopefully it has been of some use. Again, it's just the key points. If there's anything you're wanting in a little more detail, look back at the individual lessons. If you're okay with all that though, and it's making sense, well done! Woo! I'm proud of you. Try some of these questions then if you are wanting more practice. It's the TJ National 5 book, just the remember exercise. Just a bunch of fractions questions for you to enjoy. Yeah, I love it. Woo! See ya.